So today we're going to cover Chapter 4, Section 2. Today we're going to learn how to graph rational functions. So these are going to be the steps in order to graph a rational function. What we need to do is, first we're going to find the horizontal asymptote. We're just going to quickly look at the degrees. We're going to see if the top is bigger than the denominator's degree, if they're the same, or if the top is smaller. And then we'll follow the same rules that we covered yesterday. Then, in order to find the vertical asymptote, we need to simplify the expression first. Then we would set the denominator equal to 0. That will give us the vertical asymptote. Remember, if you can simplify the function and you cancel out a factor, that's where a hole will be located. Then we're going to find the zeros, which are the x-intercepts, by setting y equal to 0. But I'm going to show you a shortcut, and really all you're doing is setting the numerator equal to 0, and that'll give you the x-intercept. And then the y-intercept is setting x equal to 0. And then we're going to pick additional points, and then we're going to graph them. Now, the additional points, they're coming right from your calculator. I want at least 2 points in between each vertical asymptote. And you're going to see what I mean by that in a minute. So now we're just going to do examples. Now we're going to do everything the same that we did yesterday. We're going to find all of our asymptotes first. So I'm going to work on finding the horizontal asymptote first. So remember, for the horizontal asymptote, we have to look at the degrees. The degree of my numerator here is 0. The degree of the denominator is 1. The top has the smaller degree. So when the top is smaller, then the horizontal asymptote is always y equals 0. And I'm going to go ahead and put this on my graph. I'm just going to put it in as a dotted line. You are going to be required to graph the asymptotes. And remember, there is the rare occasion that your graph will cross a horizontal asymptote, but it will never cross a vertical asymptote. So when you're doing this on the quiz, if your graph crosses a vertical asymptote, I'm going to take points off. So make sure you're going to graph the asymptotes. You can graph them as dashed lines because technically they're not the graph. It's just going to be those boundary lines or those walls that your graph is going to skim along. So that's my horizontal. Let's go ahead and find the vertical asymptote. And remember, we need to see if we can simplify the function first. I cannot simplify it, so it doesn't have any holes. So I just take my denominator, set it equal to 0. So my vertical asymptote is going to be located at x equals 2. So let me go ahead and put a little dotted line here for my vertical asymptote. So this is the vertical. Over here was the horizontal. Next thing I'm going to do is the calculations to find the x and the y-intercept. And I want to see all this work on the PDF. Don't just copy the graph from your calculator. So for the x-intercept, remember what we're officially doing is we're setting y equal to 0. But the shortcut, and this is a little hint, the shortcut is just set the numerator equal to 0. But I'm going to show you the long way first. So if I take my function, and remember g of x, that's just a fancy way here of saying y equals. So I'm going to set y equal to 0, and then I'm going to solve this. In order to solve it, I would be multiplying both sides by x minus 2, and then 0 times anything is 0. So if you notice, what ends up happening is you're just really setting the numerator equal to 0. And in this case, there's no variable to solve for. So this has no x-intercept when you're left with nonsense to solve. Now for the y-intercept, we're going to set x equal to 0. No shortcut here. We actually have to plug in x equals 0. So y equals 3 over 0 minus 2. just plugging it into the original problem, and I get 3 over negative 2. So my y-intercept is the ordered pair 0, comma, negative 1.5, or negative 3 over 2. Now, at this point, what I would have to do is, if I wasn't using a calculator, I would do a function table. I would have set up something like this and then shown that y is equal to 3x minus 2, and then get my order pair. But I no longer need to do this. I am just going to key in this original function into my calculator, and the graph that results should look something like this. Now, on the quiz, you're going to have to list additional points. But what you're going to do is, once you get it keyed in, you would do the y equals button, and then either enter it with parentheses or enter it as the fraction. And then once you hit the graph button, this is what you get. But when you hit second and graph, this is the table that results. Now, sometimes if let's say your vertical asymptote is at 1 and negative 1, and you want to see like a half, like a 0.5, remember this instructions here that says to press the plus sign to change the table value. If you hit the plus sign, once you hit second and graph, then it'll let you change the increments. So let's say you wanted to make it go by 0.5, you can change it. For this one, I just left it going by ones, and it was fine. So now I'm going to go ahead and graph some of these additional points. So remember, I want additional points to the left. I want 2 of them to the left of the purple line, and I want 2 points to the right of the purple line. So I want points, at least 2 points in between each one of the vertical asymptotes. So my vertical asymptote is at x equals 2, so I could pick the order pair. I could plug in for my additional point. I could say an order pair, let me use a color that shows up, additional points. I could say I'm going to use the order pair 1, comma, negative 3. I could do negative 1, negative 1. And this will be for the left side. And then for the right side of that asymptote, I could say I'm going to use 3, 3. And then I would need to scroll down because I'm out of my window. I could say another one. If you guys scroll down, 5, 1 is another order pair. So I'm going to put these additional points on my graph, as well as my y-intercept. So my y-intercept was supposed to be 0, negative 1.5. Let me do this in blue. So here is the y-intercept. And then I can also graph the negative 1, negative 1. I could also graph the 1, negative 3. And then you're going to use the asymptotes as a guide. For the rest of the points, I don't need precision. You're just going to let it skim along and make the boomerang shape. And then for the other side, we said an order pair was 3, 3 and 5, 1. And then again, use the asymptotes as the guide. Do not let your line go over those asymptotes, or I will take off points on the quiz. And there is your graph. So you will list the points, the additional points that you pull off your calculator. But you will show me the calculations for the x and the y intercepts, for the horizontal and the vertical asymptote. If a graph happens to have holes or a slant asymptote, you will also show that work as well. So no longer do you need to do this whole function table, because we get the additional order pairs from the calculator. Again, I'm not looking for precision here, but at least get some points that are clear, and then just use the asymptotes as the guides. The asymptotes are like the walls that your graph will eventually skim along and get closer and closer to. Okay, so the domain, again, it's going to be always starting out as all real numbers, except what makes the denominator a 0. And that would be x equals 2. So the domain here is all real numbers, except when x equals positive 2. In interval notation, negative infinity to 2, union 2 to infinity. Okay, so for this one, I've already keyed it into my calculator, but again, I'm going to go ahead and do all the calculations. So I'm going to go ahead and do my horizontal asymptote first. So for the horizontal asymptote, remember we look at the degrees. The numerator has a degree of 1, and so does the denominator. So remember, here we look at the leading coefficient. So the leading coefficient of the numerator is a 2. The leading coefficient of the denominator is a 1. So it's going to be y equals 2 over 1, which is just y equals 2. So I can go ahead and add that to my graph. So it's a horizontal line through positive 2. So y equals 2 is the horizontal. And now for the vertical asymptote, we would try to simplify the fraction. Nothing simplifies here. Do not be tempted to cancel out those x's. They do not cancel because remember, this is attached. It's like a parenthesis around it. So I'm going to set the denominator equal to 0. So x equals 0 is my vertical asymptote, which is actually the y-axis. So here's my vertical. Doing it in purple. X equals 0, vertical asymptote. And now let's work on finding the intercepts. So remember, for the x-intercept shortcut, just set the numerator equal to 0. But essentially what we're doing is setting y equal to 0. So 0 equals 2x minus 1. Add the 1. 1 equals 2x. Divide by 2. X equals 1/2. So the x-intercept is 1/2 comma 0. Now let's go ahead and find the y-intercept. And this is where we're going to set x equal to 0. So y equals 2 times 0 minus 1 over 0. Negative 1 over 0. Remember, whenever there is a 0 in the denominator, this is undefined. So whenever you end up with a 0 in the denominator, there is no y-intercept because it's undefined. And now we'll look at our calculator to get our additional points. So I could go ahead and graph my x-intercept. So my x-intercept is right here. And then my additional points from my calculator. Notice I changed the view so it went by halves. So for my additional points, and again, I'm looking for 2 points that are to the left of the purple line. So those 2 points could be -2 and +2.5, and then -1 and +3. For -2 and 2.5, so I'm going to come over here, and then 2.5 probably around here, and then -1 and +3. And again, you're using the asymptotes as your guide. Don't make them cross. It skims along. So these are the points to the left of the purple line. And now points that are going to be to the right of the purple line. I can pick the order pair 1, 1. So I can use this one. And I could use, say, 2, which is 1.5. Again, it doesn't really matter because after you list them, you're just using those asymptotes as a guide. So 1, 1 could be here. 2 and 1.5 could be here. And again, it's going to skim and get really close to the red line, and then go down this way and get really close to the purple. So this is your graph skimming along those two asymptotes. So the domain here would be what would make the denominator a 0, and that's just x equals 0. So the domain in words would be all real numbers except when x equals 0, and then in interval notation, negative infinity to 0, union 0 to infinity. When you have two vertical asymptotes, the middle portion is going to take on either the x cubed graph or the negative x cubed graph. And in this particular example, that middle portion is taking on the negative x cubed graph. But let's go ahead. We're going to find all our pieces. We're going to find the vertical asymptote, horizontal, x and y intercepts manually, and then we'll get the additional points from our calculator. So this time, I want additional points that are going to be to the left, in the middle, and to the right. And you're going to see once I get the asymptotes on my graph. Okay, so again, you're finding the asymptotes manually. Horizontal, you look at the degrees, and the degrees, the top was smaller, so it's y equals 0. For the vertical, you had to set the denominator equal to 0. It was a trinomial that needed to be factored. It actually created two vertical asymptotes, which created 3 sections to your graph. And then you would find your x and your y intercept. In this particular case, it happened to be the same for both. They were both 0, 0. And again, you get the additional points right from your calculator. So again, I was looking to find 2 points over here to the left of that purple asymptote, 2 points in between here, and then 2 points over here. So again, and then just connect it. And again, if these order pairs happen to have crazy fractions in them, just list them and just use the asymptotes as the guide. Okay, so the domain for this one, again, it would be what would make the denominator a 0. So x cannot equal what those two vertical asymptotes are. X can't equal 2, and x cannot equal negative 1. So the domain here is all real numbers except when x equals 2 and when x equals negative 1. So again, in interval notation, negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. Okay, so for the first thing I'm going to do is look at the degrees. Notice the degree of the numerator is a 2. The degree of the denominator is a 2. The degrees are the same. So I look at the leading coefficient. The leading coefficient here is a 1, and this is a 1. So my horizontal asymptote is going to be y equals 1 over 1, which is just y equals 1. And I can go ahead and sketch that on my graph. So it's this horizontal line through positive 1. Now, in order to find the vertical, I need to simplify the fraction first. So I'm going to take my function, my g of x, and I need to factor it. The top is the difference of 2 squares. It's going to factor into x plus 3, x minus 3, and then the denominator factors of negative 3, that give me negative 2. That'll be a negative 3 and a positive 1. I'm going to look for factors that cancel, and notice the x minus 3's cancel. That's where my whole is going to be located. So now my simplified function is g of x is equal to x plus 3 over x plus 1. Now, in order to find the vertical asymptote, I take the denominator, x plus 1, set it equal to 0. Subtract 1. My vertical asymptote is located at -1. So let me go ahead and draw that line, x equals -1. The next thing I need to find is the x and the y-intercept and the location of the hole. So let me go ahead and do the hole first. So remember, the hole is located, the x value is the factor that canceled. So the x minus 3 canceled. So I set that equal to 0. Remember, the hole is an ordered pair. So far I've got the x of my ordered pair for the hole. I now need to take this x value, plug it into the function to get the y of the hole. So this gives me 6 over 4, which simplifies 3 to 2. So my hole is actually located at 3, -1.5. So let me go ahead and put that on my graph as an open circle.
Where'd you get the first?
Put this on the graph. So it's the ordered pair, 1, 2, 3, 1.5. So it's an open circle here. My graph is not going to be connected and going through that. All right, so now let's find the x and the y-intercepts. So remember, x-intercept, shortcut is just set the numerator equal to 0. And I can use my simplified function. So my simplified numerator is just x plus 3 equals 0, minus 3. So my x-intercept is the ordered pair, -3, 0. For the y-intercept, we're setting x equal to 0. So y equals 0 plus 3, 0 plus 1, 3 over 1. So my y-intercept is 0, positive 3. So let me put these 2 points on the graph. So -3, 0. Here's the x-intercept. And then the y-intercept is positive 0, positive 3. All right, so now I just need to get the additional points. So again, right from the calculator. And I need additional points to the left of the purple line. So from my calculator, I could say I'm going to use -2, which will be -1. I could also use, if my calculator was going by halves, I could do -1.5 and -3. This is to the left of that vertical asymptote. And to the right, I can say it's going to be the ordered pair 1, 2. I could also say 2 and 1.6 repeating. Again, I'm approximating. All right, so let me go ahead and get these points on the graph. And again, use the asymptote as the guide. So -2, -1 is right here. And again, it's just going to skim along. Let me do it in blue. Skim along the asymptote. And then the same thing over here. Now, for this side where the hole is located, so remember I said I was going to use 1, 2. And then I also said 2 and 1.6 repeating. So right around in here. So it's going to skim, come up to the pink, don't go through the pink, and then start up on the other side. So leave the little hole there. Okay, so the domain on this one, remember it would be what would make the denominator a 0, and what would make the denominator a 0 would be -1 and positive 3. So it's going to be all real numbers. Except when x equals -1 and when x equals 3. So in interval notation, negative infinity to negative 1, negative 1 to positive 3, and 3 to infinity. Okay, so for the first thing we're going to do is we're going to look at the degrees. This has a degree of 2 and of 1. And notice the top has the bigger degree. So that tells me that the horizontal asymptote is none. And also notice that we actually have the numerator's degree is 1 larger. So we actually have a slant asymptote. So what I need to do here is I need to do long division to get that equation for the slant asymptote. So let me go ahead and do that. So x squared minus x plus 0 divided by the denominator. So what am I going to multiply x by to make it x squared? I'm going to multiply by x. I'm going to distribute. I'm going to change the signs to opposite. I'm going to add the column. This cancels, and I get negative 2x. Bring down the plus 0. Now what am I going to multiply x by to make it a negative 2x? I'm going to multiply it by a negative 2. Distribute. Change the signs to opposite. Add the column. I don't need the remainder, so the equation for my slant asymptote is just this quotient. So it's going to be y equals x minus 2. Now, I'm going to go ahead and find my vertical asymptote. And again, I'm going to look to see if I can simplify my function. So again, my original function is g of x, and I could factor out a GCF of x. But doing that doesn't give me anything to cancel. So I could go ahead and just set, for my vertical asymptote, set the denominator equal to 0. So x plus 1 equals 0. Subtract 1. X equals negative 1 is the vertical asymptote. So let me go ahead and draw in some of these things. So no horizontal. Vertical asymptote at negative 1. So let me go ahead and draw that vertical line. Now, my equation for my slant asymptote is actually in y equals mx plus b form. So I'm going to start at negative 2, and I'm going to rise 1, run 1. So here is my beginning point, and then rise 1, run 1, and then I can make my slant asymptote. I'll go ahead and get a bunch of points on here, and then I can connect these. And make it go all the way across your graph. So this is the slant asymptote, and again, it's the equation y equals x minus 2. The vertical, was x equals negative 1. So now what I can do in order to figure out where my graph is going to be located, I still also need to find the x-intercept and the y-intercept. So for the x-intercept, remember the shortcut is just set the numerator equal to 0. So this is where factoring that GCF out pays off. So x equals 0, and then x minus 1 equals 0, and then add 1. So I have two x-intercepts. I've got one at 0, 0, and then the other one is at 1, 0. So I can go ahead and plot those 2 points. So 0, 0, and 1, 0. Those are my two x-intercepts. For the y-intercept, remember we're going to set x equal to 0. So my original function, y equals 0 squared minus 0, 0 plus 1, 0 over 1 simplifies to 0. So my y-intercept, which I've already graphed because it's also an x-intercept, is 0, 0. So now what I need to do is I need to get the additional points from my calculator. So again, we're looking for points to the left of that vertical asymptote and to the right. So my additional points from my calculator So basically I am looking for x values that are going to be less than -1. So I could use -2, -6. I could even use -1.5 and -7.5. And then points that are going to be over to the right of that vertical asymptote, I'm going to be looking for some positive values. So I could do 1.5 and 3/10. I could use 3 and 1.5. And again, you don't necessarily have to find just 2. You can find as many as you want. You know, you could do 4 because we're just rewriting them from our calculator. So now let me go ahead and graph these. So I've got 2 little boomerang shapes here. So -2 and -6, 1, 2, 3, 4, 5, 6. So down in here. And then the 1.5 and the 7.5. So again, we're just skimming along here. So that's the first section. And then I also have this other section that's going to include these 2 x-intercepts. So again, it's going to dip down here a little and then come back up and then skim along the pink line and the purple line. And again, it's not crossing it. So that would be a graph of the function when it's got a slant asymptote. Now, let me go ahead and add in the domain. And again, remember the domain is just what would make the denominator a 0. So the only thing that would make the denominator a 0 would be x equals -1. So it's all real numbers except when x equals -1. And again, in interval notation, -infinity to -1 union with -1 to infinity. Okay, so let's go ahead and let's find the horizontal asymptote first. So again, remember we look at the degrees. Top has a degree of 2, bottom has 1. So notice the top has the bigger degree. So this tells me that the horizontal asymptote is none. But notice that the top is 1 bigger. So we actually have a slant asymptote. So we're going to go ahead and do long division for that. So x squared minus x minus 2 divided by x minus 1. So we have to figure out what are we going to multiply x by to make it x squared. We're going to multiply it by an x. I'm going to distribute. I'm going to change the signs to opposite. I'm going to add the column. I get 0, bring down the 2, and that's just my remainder, and I don't need it. So my slant asymptote is actually the equation y equals x. Now let me go ahead and see if I can simplify my function and see if anything cancels. So I can see if there's any factors of 2. So g of x, factors of -2, that will give me a -1. So x minus 2, x plus 1 over x minus 1. Notice nothing cancels. So there's no holes. So for my vertical asymptote, all I have to do is set the denominator equal to 0. So x equals 1 is going to be my vertical asymptote. So let me go ahead and get that on there, as well as the slant asymptote. So for my vertical, it's just going to be this line that's going through +1. Now for the slant asymptote, it's in y equals mx plus b. There is no, the y-intercept is 0. So then I can rise 1, run 1, and then go ahead and connect these points to get my slant asymptote here. Go ahead and connect them. And this is the equation y equals x for my slant asymptote. And then my vertical is x equals 1. And this is the slant. So let me go ahead and calculate my x and my y intercept of my graph. So for my x-intercept, remember the shortcut is just to set the numerator equal to 0. And notice right here I already factored it. So it's going to be x minus 2 equals 0, x plus 1 equals 0. So add 2, x equals 2, subtract 1. So my two x-intercepts are 2, 0, and negative 1, 0. Now, for my y-intercept, I'm setting x equal to 0. So 0 squared minus 0 minus 2 over 0 minus 1. Negative 2 over negative 1 simplifies to positive 2. So 0, 2 is going to be my y-intercept. And I can go ahead and get all these points on the graph. And then what I can do is key it into my calculator and get the additional points. So let me put all this on there. So 0, 2. And then I also have the two x-intercepts, 2, 0, and then negative 1, 0. So now I can get the additional points to the left of the purple line. So for the left side, for my additional points, I could use negative 2 and negative 1.3 repeating. And I can also use, let's see if I can get another one, negative 3 and negative 2.5. And then for the right side, I could use 0.5 and 4.5. Or I could use, let me go ahead and scroll down, get some a little bit further away. I could use 3, 2. And if I wanted even more, 3.3 repeating. So let me go ahead and get some of these on the graph. This I'm put in the wrong spot. Let me move this one over. This should be 2, 0 because the ordered pair is 3, 2. And then I said 4, 1, 2, 3, 4, and then 3.3. So again, as you can see, it's going to start skimming along this slant asymptote and the vertical. And then the same thing's going to happen over here. The domain, again, is what would make the denominator equal 0. So domain, it's going to be all real numbers except when x equals 1. And again, in interval notation, negative infinity to 1, union 1 to infinity. Okay, and here's our last example. Again, we're going to do the horizontal first. So we're going to look at the degrees. This has a degree of 2. This has a degree of 1. So the top is bigger. So for the horizontal, it's none. But since the top is 1 larger, we do have a slant. And we need to do long division. So again, remember when you do long division, we need to hold the place of every single term. So now we're going to look to see what are we going to multiply x by to make it 3x squared. We're going to multiply it by a 3x. We're going to multiply and then subtract, bring down. There's nothing to multiply x by to make it a 0. X is just a 0. So my equation for my slant asymptote, because I could bring it down, and that's my remainder, but I don't need it. So this is the equation for my slant asymptote. For the vertical, remember what you would do is see if it can simplify. It can't, so I just set the denominator equal to 0. So these are my two asymptotes I'm going to get on my graph. So again, I've got the vertical, which is really just the y-axis, and then I've got the slant. I start at 0, 0, and my slope here is 3. So rise 3, run 1. So start at 0, 0, go up 3, and over 1. And then get as many points on here, and then connect them and create your slant asymptote. You can do it as a broken line, but again, this is my boundary line that I'm going to use. So the next thing I can do is find my x-intercept, and that would just be setting the numerator equal to 0. And notice what's going to happen here is I'm going to get an imaginary number, and I don't care about imaginaries. So when I try to square root -1/3, I get an I out of this. So the x-intercept is none. And then for the y-intercept, I need to set x equal to 0. So 3 times 0 squared plus 1 over 0. Again, anytime you get a 0 on the denominator, it's undefined. So this is also none. It's not going to hit the x or the y axis. So now once I keyed in my calculator, I'm just going to get additional points to the left of that vertical asymptote and to the right. So for my additional points, I'm just looking for x values that are less than 0 and then greater than 0. So for the left side, I could use -2 and -6.5, -1, -4. And for the right side, I could do 1 and 4, and then 2 and 6.5. So let me go ahead and get these in the graph. So 1 and 4. Right here. And really what it's going to happen is, and then if I go 2, 1, 2, 3, 4, 5, 6.5, it's just going to skim along here and squeeze in between the purple and the pink line. Same thing over here. If I do -1, 1, 2, 3, 4, and again, it's going to squeeze along in between here, and that would be your graph. And for the domain, the only thing that would make this undefined is when x equals 0. So all real numbers except when x equals 0. So in interval notation, -infinity to 0, union 0 to infinity. And that is it for the notes on graphing rational functions.